Alright, caches are done. I'm gonna check on load from disk so that we don't have to recalculate these steps. I'm gonna go back to the outside, turn off the pyro source. I actually need to create a dopnetwork now for my pyro simulation. So let's call it smoke sim. Okay. Now inside of smoke sim, I'm gonna actually start creating my system. I need a pyro solver, right? A pyro solver right here. That goes to the output. I need a smoke object to connect to the object input, and for the source I'm going to create a source volume. Okay, this source volume will then allow me to source the volume I created. Here that's going to be again underneath our pyro source. We have two nodes, right? Smoke source and smoke collision. I need the source here and the sept. That's going to give me the source of my smoke. Alright, and I don't have temperature, so no temperature. Right. I have velocity and I have the volume. For velocity, I'm going to change that to add to inherit the velocity and keep adding. Let's take a look at the solve to dot bindings. We don't have val, if you recall, right? When we go back to the source, we have v instead of val. We have density, that's correct, but we have the wrong velocities. I'm going to go back here to the smoke simulation and tell it to use v instead. Alright, density is density, so that should be good. Let me go ahead and also create a automatic resize, gas resize fluid dynamic, and I'm gonna change it to again not using the max bounding box, so it just updates when it needs to. Now the smoke object is actually determining the bounding box here. That's how big it is. Now there is an issue here. This position is actually at the origin. If we turn on the original rigid body distraction, here we see that that's where it is, right? Let's go back to the smoke simulation and change our visibility to show our object so we can see that. Now I want this guy to actually be at where the braking part is, which is over here, right? So one of the ways we can do is actually use the rigid body distraction part and copy. Oops. I think I'm loading that, which is not what I want. Anyway, I don't really care about that arrow. Let's go ahead and go look for this transform we did. That's where it is. So I'm going to copy this guy by copy parameter and go back to the smoke simulation. And here underneath the center, I'm going to paste the relative reference to reposition it over there too. And change the size to 2 for the bounding box, so it's guaranteed to be able to capture enough, maybe even 3, just in case. Alright, 3 might be too much. 2.5. You want to be conservative on this part, because the bigger it is, the more calculation it needs. Okay. Alright. So that is that, and the gas resize fluid dynamic, I'm also going to delay it for like 5 frames. So it's going to use this bounding box in the previous 5 frames. Afterwards, it starts to use the resize guy, which is this guy here. Alright, so let's take a look. If we start simulating, we can see the smoke being generated already, right? They're going out. Right. Cool. So one of the things we probably wanted to go ahead and change is the density here. Sorry, the division size, actually that's the quality. So 0.2 maybe is too small. Let's change that to too big. Let's change that to 0.1, maybe 0.05. Oops. 0.05 is going to be a little bit more detailed. So let's take a look. As you can see, those trails are being generated when it explodes. Alright. Again, how big they are, how much they are determined by many settings, like our original emitter, right? Our fluid source we created, or our VDB we created, right? And also the density we're reading here. Like maybe I need more density, so I can go here and change the scale source volume to 2. So we're getting more density. Right, go play it again. You can see more particles being generated down the way. Right. Okay, so that's gonna be the loading part of the source. One more thing we need to load is the collision, right? The collision we created from the geometry. That's not gonna be actually something we are familiar with, which is rigid body collision. We're gonna actually use a collision field too. So let me create a source volume one more time. And again, this source volume will be our smoke, our emitter, right? And this will be our collider. So I'm going to name this guy to collider. And for this collider, I'm going to change the volume passed to our smoke collision. Here we created underneath pyro source, accept that. Now this guy will be used to collide with our geometry. Now other things we can go ahead and really change is the surf to dot bending. We're using density to do so, but here, as you recall, our collision volume here is using surface, right, instead of density, so we need surface instead. And again, V is just V, so we need to go ahead and change that here. Surface, it's gonna be the one for the volume. The velocity is V. Now temperature is not even there, so I'm gonna say no temperature right here. Okay, all right, let's merge them together. And the merged result goes to the source. Okay, that's how we do collision here. We can actually control, go back to the viewport and space Y to turn off the visibility of the others. And then we can also go to the smoke object and turn on the collision visibility or visualization, so we can actually see if we got any collision. Let's go play with it. Now you can see, now we're getting something like a smoke. Now it's not a collision. The reason for that is because our initialize is smoke, sort of smoke. We're gonna change that to collision. Okay, that's gonna actually recalculate this. Let's play it again. Not seeing anything yet. Probably it's gonna be the reason is could be like it's resetting those things. So let's change that to surface. And this is again V. Now we're getting something really bizarre. Let's go ahead and lower down go back a few steps and start playing. As you can see, what we're actually getting is actually the reversed collision we want. It's like hollow on the inside of the chapel and becomes solid on the outside, which is kind of like what VDB is different compared to fluid source. So we have to manually change that by actually go to the scale source volume, change that to -1 to tell it, okay, we're going to use the negative direction as the actual information. Now we're getting the proper collision. As you can see, everything is actually here now. So I'm going to go back and play this again just to visualize the final result we're getting. Okay. Now we can see the explosion happening. We have those trails getting out. We have the dense smoke on those denser debris going down, right? Everything seems to be working pretty nicely. We do have some problem on those gaps between trail. Again, those kind of things can be done or fixed in our previous stage when we were generating the emitters. Or maybe we can use some, other tools like turbulence and things like that to really make those things more invisible, right? Because going back and redo that source will take more time, and also it would make the simulation slower too because of that, because we literally need more points down the way. More points, I mean here. Oops, let's go here. Take a look. More points, I mean more points here down the way. Okay. Anyway, so I'm gonna go back to the smoke simulation again and go back to frame 1, right? I'm gonna maybe try to create one more thing that we need, the essentials, two more things actually. The drag force to drag it, right? And the gravity force to pull everything down, and those are the essentials. Alright, now we have set up the basics of the mission part. Now we have the particle going out, we have them falling down, we have everything and we need as for a simulation. So we're gonna stop this tutorial now. In the next one we're gonna go ahead and do some shaping of the particles, sorry, the smoke, to just make it look more appealing. Okay, alright, thanks for watching, see you next time.